Right, this will be our last video for our preparation towards the last exam. And then in this question, we'll be looking at single phase and three-phase transformer calculations. Please remember to hit that like button and to share these videos. Now, in the first question, we'll be looking at a single phase transformer. The turns ratio of a single phase transformer is 25:1. Calculate the following. So this is a step down single phase transformer. In 8.1.1, calculate the secondary voltage if the primary voltage is 220 volts AC. In 8.1.2, calculate the input current if the transformer delivers 10 amps. So the first thing we do before we answer the question is to draw the core of the single phase transformer. I write down the ratio right in the middle of the core so that I can see it clearly, and we write down any values that are given and the values that are unknown. Remember, the formula or the equation is V1 over V2 is equal to N1 over N2, which is equal to I2 over I1. Right, to calculate the secondary voltage, this is the equation we're going to use. V1 over V2 is equal to 25/1. V1 is equal to 220 volts. So therefore, V2 is unknown. It is below the line. So therefore, we're going to swap. So V2 is equal to 220 times 1/25, and we get 8.8 volts for the secondary voltage. Now, to calculate the input current of this single phase transformer when it delivers 10 amps to the load, the equation is I2 over I1, which is equal to 25/1. I2 is given, it's 10 amps, so therefore I1 is unknown. Once again, it's below the line, so we are going to swap 25/1. Therefore, I1 is equal to 10 times 1/25, and we get 0.4 amps. Right, and our final calculation for this preparation series, it is a three-phase transformer calculation. A three-phase delta-delta transformer is connected to a 2.2 kilovolt supply. The secondary phase voltage is 220 volts. Now remember, unless specified, we will always assume that line values are given. So on the primary side, we have 2,200 volts for VL1. So therefore, we can assume that V phase 1 is also equal to 2,200. We are given the secondary phase voltage of 220 volts. So therefore, we know that V phase 2 is also equal to 220 volts. The formulas for delta, VL is equal to V phase, and IL is equal to square root 3 times I phase. Right, in 8.2.1, calculate the primary phase voltage. So VL1 is equal to V phase 1, which is equal to 2,200 volts. In 8.2.2, calculate the secondary line voltage. Once again, on the secondary side, it's delta connected. So therefore, VL2 is equal to V phase 2, which is equal to 220 volts. To calculate the primary phase current when it draws 120 amps from the supply. So therefore, I phase 1 is equal to IL1 over square root 3. Now, in terms of the 120 amps from the supply, they do not specify whether it's line current or phase current. So therefore, we are going to assume that it is line current. So 120 divided by square root 3 gives us 69.282 amps. Right, I hope you enjoyed this series that is preparing you for test 2 and for the national exam paper. Thanks for watching these videos and for supporting. Thank you.